Well, first of all, I want to thank you guys. It was an amazing conference, as I want to say as always. I mean, it's been 2 times so far, but it's been great again. And you took great care of us, which I appreciate a lot. Who of you is still awake? I know it's been tough 2 days. Yeah, a lot of hands. That's great. All right, so I want to talk about the attack landscape of 2020, what to look out for and how to protect yourself. Short word about me. My name is Pascal. This is a way too big picture of me, but who cares? I was also told today that this picture doesn't fit anymore because my hair looks different. But hey, get older, the hair grows longer. I'm an IT security engineer at Dynatrace. Dynatrace is an application performance monitoring solution. You can find me on Twitter under my handle Pascal Sec. I'm also going to post the slides of this talk over there either tonight or tomorrow morning. Quick word about Dynatrace. We have a pretty nice new office building. We do cool tech. We have a nice cafe in our building with a barista, and all the other stuff I'll let you find on the internet, because believe it or not, we're there as well. A little disclaimer, I will show you a couple of tools, products, and solutions, but I'm not affiliated to any of those. I'm not getting any money. It's just tools that I like to use. Quick agenda of what we're going to look into. I want to give you an understanding why it is important to look at the attack landscape. I want to give you an idea how you can find information about it. So this talk is only covering a little bit of it. I want to give you an idea how you can search for it by yourself later. And then we're going to look into 4 vulnerabilities out of the past that are pretty common these days. So why is it important? We have heard by a lot of people, Philippe was one of them, about Equifax in 2017. Also in 2019, last year, there were a lot of major breaches. The most prominent one probably was Capital One's breach with, if you look at the slides, more than 100 million records breached. And they are a bank, and they breach stuff like zip codes, phone numbers, email addresses, birth dates, self-reported income, customer credit scores. Just imagine that data being out in the wild of you. You probably don't want to have that. You can do a lot of silly and malicious things with that data, like impersonating somebody, running some phishing scams, whatever. Not really what you want to have. A few others were eBite, American Medical Collection Agency, and so on. A lot of records breached. Also, if you want to get an idea, I talked about this yesterday in the expert panel. This is a pretty cool podcast, and it's like a high-level view that you get while listening to this, but it's pretty nice. So you can just tune in while, I don't know, going to work, doing your morning commute, and just listen to the actual stuff that is happening in the world of cybersecurity. And there's a lot of bad stuff going on. And this podcast does a nice job in explaining that to you. So how? How can you keep up to date? Because obviously this talk is now, but you want to keep up to date for the next 30 years. And I just want to give you a couple of nice sources and resources that you can use at any time. So we have heard of that before, which is the OWASP Top 10. I guess most of you know. Basically giving you a high-level overview of security vulnerability categories like injection vulnerabilities, authentication, sensitive data exposure, and so on. This list is updated every 3 years. And as you can see, this is the 2017 version. So if you do the math, in 2020, there will be a new version coming out. I cannot give you the latest insights of that version because according to OWASP, their plan is to release it around October 2020. And it's their #1 agenda point in promoting this because everybody knows that. And it is a pretty cool list. So check it out when it's coming out in October. Until then, what can you do? You can go to a security conference like this one, and this is actually a screenshot of last year. You see Fefe sitting there in the front. Like, I don't know if you were here. Some of you remember Fefe. He's there. It's just important to listen to what is being said in the talk and don't be that guy who's playing around with his mobile phone, because then you will not really learn anything new. Yeah, so where is my data coming from? I did collect some high-level data and some more detailed data. And so we are running a bug bounty program. And for those of you, so who knows what bug bounty program is? Hands up. Yeah, like 70%. For those of you who do not know what it is basically a concept where you give money to people reporting vulnerabilities to you. So there's a lot of people in the world finding stuff in your applications. They're reporting it to you. You're giving them $1,000 for a medium finding or whatsoever. And with that, you don't really see it in that screenshot, but we got around like 50 reports by now. So we have some ideas what is trendy, if you want to say, in what people are currently looking for. Also, well, if you want to find out more about the program, just head over to that link later. Also, we're running this program on HackerOne. HackerOne is just a service provider where you give them money and they have a couple of services for you, like they're triaging the findings, whatsoever. Don't want to talk too much about it, but what they do is they run this for a lot of companies, not just Dynatrace, but for 1,400 different ones. And HackerOne claims to have one of the largest and most robust databases of valid vulnerabilities. And I believe them because, as I said, they run a lot of different programs for a lot of different companies. And that includes companies from a lot of different fields, like technology unicorns, government startups, financial institutions, and a lot of other stuff. So what do they do with that data? It would, of course, make a lot of sense if you create some metrics out of that. And as I've said before, let's start with the high-level overview. So this is the data from like a week ago. So they have a live view of the metrics. And it surprised me, to be honest, to still see cross-site scripting on rank #1. Like, in my opinion, it doesn't really make sense anymore to have cross-site scripting vulnerabilities because it's so easy to prevent them. But hey, it is what it is. It is the actual data. If you check out the other pieces of the pie, it's improper authentication vulnerabilities, information disclosure, and a couple of others. We will dig into some of those later in more detail. So this is the high-level overview. If you want to get a deeper understanding of what people are actually doing, and I said this yesterday, you need this. You need to understand what hackers are doing in the wild, because otherwise you cannot fix your own issues in your code, right? And once again, I'm referring to HackerOne here because it's rare that you have a source that publishes so many new findings, and the activity, again, check it out later, I'm giving you pointers today, is a page where you have a listing of publicly disclosed vulnerability reports. So those are actual findings. Whatever RadTube paid out $1,000 to John Doe, click on it and you see how John Doe achieved to find that exploit, right? And this is pretty cool because you see the attacks evolving and you always get new ideas, and with those ideas you know how to fix them. What else? Portswigger. Who in here knows Portswigger? Mostly the hackers. Portswigger is a fantastic company. They are the company behind a really famous tool called Burp Suite, which is the hacker's favorite tool to use for penetration tests. And they have also something really cool, which they call the Web Hacking Top 10 of, well, every year. They started in 2003, and this got published a week ago. It's a little cut off, but you can see it says February 13th or something like that, whatever. It's not old. This is the latest list of, so what they do is they collect the most fancy ways to hack applications. They collect them, they take these nominations, and they have a little panel that selects the top 10. So every year you get 10 brand new ways to hack applications. And that's pretty cool because those are usually ways you haven't thought of or wouldn't have thought of in a million years. So those are pretty great findings. Just to give you an idea, like the top 3 this year, again, look into the details later, but the top 3 were owning the cloud through server-side request forgery. We're actually going to look into that later. Cross-site leaks and web cache deception. If they sound familiar to you, they're not entirely new, right? It's just new ways how to find a vulnerability in those areas. Right, so let's switch to the what. I want to show you 4 vulnerabilities today. And I want a little short disclaimer again, they're not new. So none of these are, I don't know, like brand new 0 days, whatever you want to call them. Those vulnerabilities have been existing for a long time. It's just that new variants were coming out. People posted them on Twitter, on different other forums, and then hackers all over the world, they follow those people with really good ideas. They look how they are breaching an application, and they try to replicate those ways on different applications, different platforms. And the 4 ones that I'm going to show you right now are such ones which we have seen more often throughout the last 2 years. So subdomain takeover. Again, the question, who of you in here knows what a subdomain takeover is? Well, that's like 50%. So let's have a look. I actually divided my example into, if you look at above, it says company level, and later on there's dev level, but we'll explain that later. So on a company level, imagine you are running a company, and your company has a domain, yourcompanydomain.biz. And for some reason, you're super excited about this new stuff that you're doing, and you want to blog about it, and you get yourself a different domain. You buy yourcompanyblog.biz because you think it's a good idea to have 2 different domains, and then the blog can be found on that domain, and your customers can go there to read your blog. So the problem is your customers, for some reason, don't really find this website. They're used to go to yourcompanydomain.biz, but they don't find the blog. Management doesn't like that, so they say, we've got to do something. What if we create a subdomain? And they create a subdomain, and they name it blog.yourcompanydomain.biz, and pointing via CNAME DNS record, the canonical name DNS record, to the actual blog, right? And what happens if, so this is the DNS record down here, if you would run a DNS query, and what happens is, if you go to blog.yourcompanydomain.biz, you see that domain in the URL. So it doesn't change, right? It's the stuff that you see in the URL bar. But you would actually browse that application down below. And then a little later, I don't know, 5 years later, your trajectory has shifted. And now the blog is not worth anything anymore because it's now you, I don't know, post all your stuff on Instagram because Instagram is pretty cool. So you just neglect it. And the domain lease is running out, and I don't know, nobody really cares anymore about it. And then at one point, an attacker goes over your DNS entries, and he finds that, which is again listed down below here. And he's like, hey, interesting, let's look if your companyblog.biz is available. So he goes to any random website on the internet where you can check domains, and he checks it, and it says, well, it's available. It comes for £7.10, or pennies, I guess you would say, if I say pounds. And he just adds it to the cart, pretty easy. 10 minutes later, he owns the domain, and he can do whatever he wants with it. So we're having this situation. Obviously, if you are owning the domain, you, I don't know, set up a web server and run whatever you want on that web server. At this point, the CNAME record is still pointing at the domain. If you notice a change right now, obviously, people could go to yourcompanyblog.biz, which is a completely different domain than yourcompanydomain.biz, but they could still go to blog.yourcompanydomain.biz. And at this point, the world is changing a little bit because right now it's the same domain. It's just a subdomain of yourcompanydomain.biz. And this leads or can lead to a lot of security issues. An example would be, classic example would be phishing, right? Like people look at a domain, they're like, hey, I know this. I mean, this is the domain of this very reputable company. I trust them. I do whatever they want from me on that domain. But in real, it's the attacker controlling this domain. There's also other issues, poorly scoped cookies, and a lot of other stuff. So that's a bad situation. Dev level. Why did I separate this? You might be wondering right now, as a dev, I don't really often buy domains for my company. Yeah, that might be true, because that's usually handled like an upper level management or something like that. But hey, you can open up, for example, a GitHub Pages page. I guess a lot of you are familiar with GitHub Pages. You can just go to GitHub, create a repository, and the way it works is if you put down an entry into your repository named CNAME, then it is reachable once again with a CNAME DNS entry. And for example, this could be needed. Let's say you're having any source, any kind of open source ideas that you wanna run on GitHub itself, and you set it up on GitHub, and you point to it. You ask your DNS administrator. He does it for you, and now you have a subdomain pointing to your GitHub Pages website page. And this, I guess, happens quite a lot of times by developers. So what happens, and I don't want to say if the employee gets killed, as we've heard today, if he gets terminated. Well, if he gets fired, this guy might be mad, or he just doesn't, I don't know, he might want to do something stupid to the company, or he might just want to get rid of the repository, and he drops it. So now the repository, the GitHub Pages repository, is free to take. Somebody claims it. Again, an attacker, by the way, as before, an attacker finds that DNS record here, checks if it is available, finds this screen over here, which basically tells him, well, this GitHub Pages site is not here, like it's up for grabs. And he's like, hey, great, sweet, so I'm going to claim it. And then you end up having the exact same situation as before. You could browse to Opensource GitHub.io, which is the GitHub Pages site, but you could also go to opensource.yourcompanydomain.biz. Same situation as before, same cookie problems, same phishing problems, whatever. Like, you can come up with creative ideas what you can achieve with a situation like that. And there is similar issues with Amazon, Heroku, Shopify, a lot of others. That also works with name server entries and MX DNS entries, so don't just look at CNAME records. Cannot go into that right now because that would take a long time. Anyway, what do I need you to do? The easy solution is a paid service, right? You can just look up if your DNS provider has a service included, and a lot of them do, which constantly scans if you might be prone to a subdomain takeover vulnerability. But if you don't want to pay for it, or if your DNS provider doesn't has such capability, you can buy services by other companies. Again, a paid service by Detectify in that case. But if you don't want to pay for it, you can obviously go for the self-service solution. And there's a pretty nice GitHub page by a guy called @overflow, which he named "Can I Take Over XYZ?" And what you could do is you could automate, write a little tool that takes the DNS zone file, checks if there is CNAME records available, check what they point to, and then see if you get a fingerprint back, the ones which are listed over here. And if you get the fingerprint back, you know that this actual page on wherever people used it, like on the left side you see the services, then you know if they're still used or not used anymore. And if they're not used anymore, get rid of the CNAME DNS record. That's really important. So you could basically write yourself a little tiny monitoring tool. Is this tool already out there? I don't know. I still have to write that by myself. If I've done that, I'll let you know. But this is a pretty good way to do it. Metadata RF. So this is another one that I want to dive into, and we've heard about that today already by our lovely friends out of France. I don't know if they're still here, but I don't see him. Whatever, I will explain it to you one more time in a little bit of a different version. Metadata SSRF, let's break them up pretty quickly into two parts. So metadata, I'm speaking of cloud service provider metadata APIs. So what that means is AWS, GCP, Azure, they all have metadata APIs, and you can query them to get some information. So that's the metadata API part. What is a server-side request forgery? That is basically if your website, for example, you have some capability to talk to talk to webhook or something like that, then the server obviously has to send a request. And an SSRF vulnerability is if you can forge that, manipulate that, so that the request is going somewhere else. And metadata SSRF, quickly explained, is you would like to go to this metadata API, but you cannot do from outside the network because it is a linked local address, right? You cannot just go there. But then you find this SSRF vulnerability, and suddenly you only need port 443 anymore. You browse to the website, and you manage to request the API from the inside. And there is maybe a good chance that you get some feedback, that you can read out the data, or if there's not, you can still change some data. This works with a ton of services. This works with AWS, with GCP, DigitalOcean, Oracle Cloud. Don't read that right now. There's even a link to more by Jason Haddock's, really good resource. Make sure that you do not expose those to your server. A little demo, a little recorded demo. I'm going to narrate it. So this is Portswig, I've mentioned before, pretty nice company. They have a vulnerable web shop that you can use to play around with that vulnerability. And what you see here is a basic web shop. You can go to products and click on check the stock. And then it tells you down below here, it's 410 units left in stock. And you fire a burp, whatever you get penetration tester would do. You check it out, it says, that's XML. That sounds already fishy. So now there's another vulnerability coming into play called an XXZ. I'm not going into too many details, but we're basically using an XML external entity vulnerability here to query Amazon's metadata API. If you look at it, product ID is 1, and now we're going to fill in a doc type tag. So this is in pretty short how it works. There is the entity called XXZ, and it's pointing to the linked local address that you've seen before. And right now we're going to adapt the values a little bit. So if we leave the product ID at 1, it still says 410 units. If we say XXZ semicolon, which is not the correct way to do it, I was just playing around with it, we still get, we actually get an error, which is pretty interesting. And then if we use the entity, we suddenly see latest. And if you're aware of the API, you immediately realize that looks a little bit like a metadata API. So you just fill in latest on the left side, and suddenly you get metadata. And now it's starting to make sense, right? You just go ahead. In this case, you actually get pretty nice feedback. It's a demo vulnerable application, don't forget that, but you get nice feedback. You keep going, IAM, then it says security credentials. Sounds super interesting, right? Like, we definitely want to know what we can find there. And then, boom, it says admin. What else do you want? We gotta check it out. So you fire in admin, and there you go. You have like access key ID, secret access key token, and whatsoever. And you can imagine that you could do a lot of bad stuff with that. So what do I need you to do? We've heard this today. Whitelist your IP ranges or your DNS names. So it doesn't really make sense to be able to call the metadata API because you don't really need that from your web app. In those cases, I suppose. If you, for example, need access to a database, whitelist that database. Like, you're still allowed to access different services in your network. Don't be afraid of that, but just whitelist it. also use authentication, it's not said that just because it is your internal network, there won't be an attacker somewhere around going, knocking at it, visiting it, and getting the data, right? Like authenticate. Disable unnecessary URL schemes. Also that we've heard today. So there's a couple of pretty weird ones out there, like the Gopher scheme. A lot of people don't know. And it could happen that with that, you bypass the whitelist or the protection you have in place, and you could suddenly query it again. So take care about that. Another one is monitor the response. Because if you implement an application and you know what the request is supposed to do, you usually also know how the response looks like. And you could monitor it if it looks legit or not. If it doesn't, like if it contains metadata, then just drop it, like don't send it back to the user. All right, let's head over to another one. HTTP desync attacks, also known, aka request smuggling. Who has heard of request smuggling? I guess, again, 50%. Pretty big in the news, found by an extraordinary researcher called James Kettle. And I just want to give you an idea what it is. Let's look at that picture. What we see here is a situation where we have two users. They are sending HTTP requests. We're having a front-end server and a back-end server. Front-end server usually being a thing such as a proxy or a load balancer. And the requests are getting collected, and then they're getting forwarded, for example, in our case, to backend server number 2. We see 4 requests by user number 1 coming in, and 3 requests by user number 2 coming in. Let's quickly remind ourselves how a request looks like. In that case, it is a post request to sec4dev b9, whatever. It has a content length of 19, and it specifies that the post body has 19 characters, which are test param equals test value. I guess that most of you have seen before. Surprisingly, there's a different way to do that with a transfer encoding chunked header. That not so many people know. It does the exact same thing. It sends a post payload with test param equals test value to the server, but it works a little differently. The way it works is now it says chunked, and then it says 13, meaning that there's 13 characters coming, and then it says 0, and 0 terminates the request. All right, so we learned that there is a new request header. That's nice, but not really helpful. But what happens if you use both? If you look at it closely and think about what we've just learned, we see content length is 17, which is all the stuff from the 0 to the final S in sec4dev rocks. And we see chunked, meaning that after the 0, the request is over. There's nothing coming afterwards. So if the front-end server and the back-end server behave differently, you might already see that this could actually create an issue. And I'm going to show you a demo right now in which the front-end server works after the content length, or respects the content length request header, and the back-end server respects the transfer encoding request header. And what that means is, if you look at that picture, there is the X in the middle, which is the manipulated request coming in, and the front-end server forwards it, the full piece, to the back-end server, and the back-end server then says, well, okay, so up to the 0, it was coming from user 1, but everything else belongs to the next request. And as the next request was coming from user 2, it says it belongs to user 2. So how does it look like in a demo? Once again, thanks, shout out to Portswigger for another pretty nice lab of theirs. In that case, we're having a blog. And we're opening up our favorite tool once again, which is Burp Suite. We're taking any request, doesn't really matter. We send it to the repeater, and we are going to change the HTTP method to post. And we are going to put down the content length and the transfer encoding request headers as we have seen before in my slide. So let's do that. Content length is 17. Transfer encoding junked. Now we're going to say 0, meaning that the request is over. There's nothing else coming. But in fact, there is something else coming. There's another little tiny part of the payload, sec4dev rocks. And we're sending that once. We're getting a regular response. We're sending it another time. And what you see right now is it says, I don't really know the HTTP method. What in the world is sec4dev rocks post? That is not a valid request HTTP method. And what happened is that the final piece, obviously you got it, was attached or pre-pended actually to the next request, which is bad. In this demo, you don't really see an exploit where you can get data or something like that, but read up on it. There is a lot of stuff James Kettle did. He earned like $89,000, $40,000 by solely hacking PayPal. Also to be found on HackerOne's activity. Great stuff to read. What do I need you to do? So there's a couple of things you can do. Use separate network connections. If you send every single request over a separate network connection, that just cannot happen. Like, there's no way something can go wrong. What else? Use HTTP 2 for backend connections. So with HTTP 2, you don't have any ambiguities, and that just doesn't work anymore. It's designed that way. What else? Use the exact same configuration and server for your front-end server as for your back-end server, because if they understand the request in the exact same way, there's not really a chance that something can go wrong, which I guess makes sense. All right, final one for today. Public secrets disclosure. Yesterday I was talking about a tool, and this is a screenshot of it. I'm going to show it to you right now. I'm actually going to click on it right now and let it run for a bit and explain it to you what it does. Gotta move it over here, I guess. Whoops. So this tool is called Schgit, and what it does is, or I'll explain the problem first. The problem is that more and more services all over the world demand that you use tokens, secrets, whatever, passwords, and much more. And the issue is that you should not post them into source code, and you really have to be aware that you don't do that. Like, a lot of times that happens by accident, and you didn't really want to do that, but it just happened, right? And what this tool is doing, it just demonstrates the issue pretty nicely. This is the reason why I'm showing it to you. Don't know the guy's name, but he's going under the nickname of Dogport on Twitter. He is pulling all commits or all pushes from GitHub and GitLab off their API, and he uses regex to look for well-known patterns in those files, and then he the tool finds a lot of interesting stuff. And actually, don't see it anymore on my screen right now, so I gotta walk out a little bit here. What have we found by now? We have found Google Cloud API keys. We have found potential private keys, PAM files. We have found shell configuration files, Ruby on Rails database configuration files. All that was committed in this last minute since I've opened up this page. This is not good. I can show this to you because it is public, right? But I do not encourage you to take that right now and do something bad with it. You can go, what you could do is, you could click on the little flag over here, which brings you to the create issue page of this repository, and then you can flag this under your name. If you want to be a nice guy, a nice person, do that. Let him know that he just published a Google Cloud API key. All right, let's switch back to the presentation. Is that the presentation right now? No. Yeah, it is. What do I need you to do? First of all, I guess, building awareness and enabling employees the most important point. So all of you here who have been watching this presentation, who were listening actively, take it back to your folks at wherever you work and let them know once again that you really do not want to end up in Schkit, because that is terrible. So raise awareness, take it out, and let everybody know that secrets in source code is really bad. This is pretty nice, but what can we do against it? Then developers come and say, well, but we need our secrets in the source code. We cannot, we have to put them somewhere. There is a lot of solutions for that. I guess most of you in here have heard about HashiCorp's Vault, which is a pretty well-known solution for managing secrets in code. Use that. Or if you are more in an AWS environment, use AWS's Secret Manager. There is a ton more. There's similar services by Azure, by all the other big services. Just Google for it and make use of them. They're not super hard to use. What can you do without those services? What can you do immediately? Use pre-commit hooks. What that is, I'll show you an example right now on the screenshot. We have made good experiences, for example, with Git secrets. What that is you install that, pre-commit hook is created on your host. The disadvantage is that everybody has to install that on their own machine. And it does the exact same thing. It uses regex to check if you would be about to commit a secret. And before you are actually committing it, it tells you, hey, look, you have a regex that is getting flagged because you were just about to, I don't know, like commit this highly sensitive API token of yours. And you probably think about it twice and get rid of it out of the source code. So that is a pretty nice thing to do. A little caveat is, what if your secrets are cannot really be covered by a regex because it's too generic? Well, that's a stupid situation. In that case, I suppose, or I would suggest to create a secret format that is individual to, well, all over the globe and to your company. So come up with like a little whatever, like a prefix or something that you use to make your secrets identifiable, and that helps you to get rid of false positives. That is on your own machine. Works pretty well. I would highly recommend to use it. Another thing you can use is GitHub token scanning service. That is working on a global scale. So what that is, it is a service that is for free by GitHub, and it's the same principle. You give them regex and they scan all their code for that regex. When do they scan it? They scan it in two situations. Either you push new code into a public repository, or you move or make a private repository public. So those are the two situations. If you do any of those two actions, it will get scanned, and you will get informed. They're only informing you. They cannot delete it. I mean, they could, but then this would have potential of a denial of service attack. So they're only informing you. What you're doing with it is up to you. All right. The sources I'm not going over, obviously. I only want to make you aware of one more time that I've put down a lot of interesting sources for those 4 vulnerabilities that I've shown to you into my presentation. They're all here. It will be on Twitter. Go check it out, read about it, learn, and remediate the issues you might have in your own applications. With that said, I am happy that you guys were listening, and I'm open for any questions you might have right now. Thank you for listening.
Thank you, Pascal. Now, questions from the audience. I like the first one, or the most upvoted one. Were your parents cool programmers and therefore named you Pascal?
Unfortunately not, no. And I have to admit, I've never used the language. I guess I still have to, but I don't know how to use it.
I learned it in school the first year or so.
Yeah? I will do.
It's not as cool as you are, of course.
Oh, thank you.
Okay, next question.
Okay, let's move on.
What current HTTP servers are vulnerable to desync attacks?
I just recently read about Kettle, which had a vulnerability in one of the latest versions. It's patched by now, so
Java-based web server, right?
yeah, you can update it, or you should update it. I mean, patching is always #1 thing to do. Keep your stuff updated. Any others? I don't know. Like, I'm not following all the CVEs out there.
Isn't that something that has to be fixed in the HTTP servers instead of the developer taking care of this?
Yeah, it has to, but unless they do so, there is still stuff that I've shown which you can use to well, protect yourself while the server itself is still vulnerable. Or a lot of times they might even don't know that there is a vulnerability in it, right? There might be some more 0 days out there, and while those haven't been found by any security researchers out there, you can still use those remediation steps that I've shown to be on a secure side.
What's your recommendation on securely distributing secrets between many developers?
Between many developers?
Yeah.
Well, it's exactly those services that I've shown. Like, it depends. Thank you for that. In which infrastructure you're operating, but like I've said, if you're heavily AWS-based, you can use Secrets Manager, and that service is offering capability for that.
Is there any project like Schgit I can apply on our own repositories or other tools in our company, like for example Jira?
Yeah, so Schgit can be found on GitHub. You can just blatantly steal all the regexes and use, for example, Git secrets that I've shown you as well. Just smash them in, and Git secrets not only works on a per commit basis, it also works in a way where you can scan your entire repository, not just repositories that are publicly available. You can just scan it on your local machine. And then if you have all the regexes installed, it will find a lot of issues.
One question I can answer, very informative, so your presentation is well perceived. Is the presentation available for download? Yes, all the presentations are going to be available for download after the conference. You will get an email as attendees. There's a question down there that is not right now the most upvoted one, but I want to ask you because I find it particularly interesting. Which kind of cookie problems do we get with the subdomain takeover? Aren't they scoped only to the subdomain?
Well, no, you can scope them. Well, the scope is freely settable, is that a word? By the application owner, right? Like, you can set them to asterisks, and then all the subdomains would get them.
Okay. Okay.
Fine. So, thank you.
That's it. Thank you, Pascal.
Thank you.